All right, so we're starting section 2.1, starting chapter 2, and the first half of chapter 2 is kind of getting you ready for the second half of chapter 2, which, wait for it, is all different types of story problems. So this is a pretty intense chapter, so know that going in you might have to watch some of these sets of notes a couple of times, some of the examples a couple of times, to be able to comprehend all of the content. All right, so starting off fairly simple, we are going into a little bit of algebra. So we're going to be talking about some algebraic expressions and some operations that we can do with them. So first of all, a couple of definitions. So what is a term? And a term is a product of numbers and variables. Product meaning multiply. So for example, if I write down a couple of examples of some terms, 3x squared y would be a term. It's a product of numbers and variables. 6 would actually be a term. It doesn't have any variables, but that's okay. It's actually called a constant term. The term a to the 5th, b to the 6th, c would be a term. Remember, there's really an understood 1 in front of there. So that would be a product of numbers and letters. So every term has a coefficient, and the coefficient is the number part of the term. So if we look at the terms that we looked at in the definition of term, you can see that in this first one, the 3 is the coefficient. In the second one, the 6 is the coefficient. And in the third example here, the 1 is the coefficient. So the last thing we're going to talk about is, what do we talk about when we're talking about like terms? Well, like terms are terms that have the same variable part. And like terms are important because we're able to combine like terms by either addition or subtraction. So for example, 2x and 5x would be considered like terms. A squared b and 10a squared b would be considered like terms. 3 and 8 would be considered like terms because they have the exact same variable part. They have no variable at all. So I could combine those two numbers by either using addition or subtraction. So that's what we mean by like terms. So let's go ahead and let's do some examples of how we would do some simplifying by combining like terms. So if we look at example 1a, we have a 9y and a negative 4y, so we can see that those are like terms, so I can combine them. And the way you combine like terms is you combine the coefficients, and then the variable part stays the same. So for example, 9y minus 4y would simply be 5y. For b, 11x squared plus 1x squared, remember there's an understood 1 there, would be 12x squared. The variable part stays the same. Now if we look at c, they're not all like terms, but we have a negative 3x and a positive 6x. So I can combine a negative 3x and a positive 6x, which would give me 3x, and then I have this positive 5y to go along with it. And you cannot combine those because they are not like terms. If I look at d, they are all like terms, remembering that the coefficient of the middle term is actually a negative 1. So 14 and negative 1 is 13, plus 3 is 16 m squared, combining those. If we look at 1e, we have a negative 7a and a negative 1a. That's going to give me negative 8a. And then we have a negative 2 and a positive 5, which is going to give me plus 3. Going on to f, we've got 2/3 x minus 2x. So those are like terms. We can combine them. So we want to, I'm just going to use some scrap over here to do 2/3 minus 2 over 1, remembering that you have to have a common denominator, which is going to be 3. So top and bottom here have to be multiplied by 3. So now I have 2/3 minus 6/3. And you can see when I do 2/3 minus 6/3, I'm going to end up with negative 4/3 x. Now let's combine some things that we had in the previous chapter here. You can see where the first thing I would have to do to simplify is to remove the parentheses. And I'm going to do that by using my distributive property. So 3 times 11y would be 33y. Plus 3 times 6 is 18. These are not like terms, so you cannot combine them. So that's as simple as it gets. Moving on to h, again, we have some distribution. So negative 4 times x would be negative 4x. Negative 4 times 0.2 would be negative 0.8y. And the negative 4 times negative 3 would be plus 12. None of those have the same variable part, so we cannot combine any of those. Let's look at I. This negative has to be distributive, or think of it as a negative 1. So negative 1 times 3x is negative 3x. Negative 1 times 2y is negative 2y. Negative 1 times z is negative z. And negative 1 times negative 1 is a positive 1. And again, if you look, there are no like terms. So that's as simplified as it gets. Going on to j. Just move my paper a little bit. Again, we have to distribute to eliminate the parentheses. So 4 times 4x is going to be 16x. 4 times negative 6 is negative 24. And then we have the plus 20. We don't distribute through to the plus 20. There's no like terms to combine with the 16x, so that's going to stay the same. But we have a negative 24 and a plus 20, which gives me a negative 4. Let's go and let's look at k. You can see I have 2 sets of parentheses to eliminate, so that means I'm going to end up distributing 2 different times. So negative 3 times 7x is negative 21x. Negative 3 times positive 1 is negative 3, remembering that there's a negative 1 out here. So now we do negative 1 times 4x is negative 4x. And negative 1 times negative 2 is a positive 2. Make sure you're watching your signs. We can combine negative 21x with negative 4x. That's going to give me negative 25x. And we can combine the negative 3 with the positive 2, which would give me negative 1. And again, we can't simplify any further because those are not like terms. Now look at L. We have to be careful. We don't even think about it, adding the 8 and the 11 first. We always have to eliminate the parentheses first. We're eliminating the parentheses by doing distribution, which is multiplication. And of course, your order of operations says you would multiply before you would add. So this 8 is going to stay the same. Plus, now here we go, 11 times 2y is 22y. And 11 times negative 9 is minus 99. Now let's go ahead. We can combine the positive 8 and the negative 99. So we'd end up with 22y. And if I combine 8 and negative 99, I'm going to get negative 91. let's move on. We have a little bit more. Again, kind of inching our way up to solving some equations. So in example 2 says write each phrase as an algebraic expression and then simplify. So again, what we're basically doing is we're taking the English and translating into algebra. So this one says that we have 3 times a number x subtracted from 10. So we have this 3x and it's being subtracted from 10. That is going to be 10 minus 3x, not 3x minus 10. The 3x is coming from or being taken away from the 10. So that's what that algebraic expression would look like. If we do b, the sum of a number b and 2, and what are we going to do with that sum? It says we're going to divide it by 5. So the sum of b and 2 would be b plus 2, and we're taking that sum and dividing it by 5. So that's what that's going to look like. Let's look at C. 3 times a number z added to the sum of the number and 6. So 3 times a number z, that would be 3z, and it's being added to the sum of that number and 6. So it's being added to the sum, so that would be z plus 6, and we'd have to put that in parentheses because this is being added to the whole sum of z and 6, which would be z plus 6. And last but not least, 7 times the difference of a number t and 4. So 7 times, what are we multiplying by 7? We're multiplying the difference of t and 4. So we're multiplying the whole difference of t and 4. And there's our 2.1.